featuring a panel discussion on innovative technologies. Gain exciting insights into future trends. With panelists Jean-Marc Sinnacombe, Michelle Kieran, Joel Fink. Moderated by Claudia Van Born.
Hello and welcome to the ITMA Live panel discussion on innovative technologies. Our topic today is smart textiles. As you know, consumers have developed an unrestrained desire for smart daily aids in all areas of life. This trend can also be observed in the textile sector. The expectations placed on a textile have changed, and the increased requirements demand intelligent solutions. Consumers today expect multifunctionality. For example, they want to be able to communicate with the help of textiles. Such smart textiles are realized through specifically integrated electronics. According to forecasts of independent market researchers, the global market for smart textiles will be worth about $1.3 billion by 2031. The prerequisite for this is an efficient combination of textiles and electronics, which offers sufficient technological flexibility for different application scenarios, from body-hugging clothing or medical textiles to architectural elements. And for today's discussion, we have put together a very interesting panel to share their views on this exciting topic of smart textiles technology, which combines classic textile technology with ultra-modern electronic application. It's my pleasure today to introduce to you the three panelists with me here today. Let's start with Dr. Jean-Marc Sinnacombe, a chemical engineer with a PhD in composite materials, with 20 years of expertise in material innovation. He is the global head of research and development at Porsche Industries, managing 3 research centers worldwide with over 200 active patents. The second expert is Michael Kieran. He has been with the Karl Mayr Group for almost 20 years, from textile development to product management in new textile technologies. Currently, he is business development and product manager at Karl Mayr Stoll R&D, specialized in tailored fiber placement in warp knitted structures and integrating technologies of additive manufacturing in textile chain. The third in the group today is Professor Joel Fink. He is a professor at the MIT in Cambridge. He holds a BA in physics and a BSc in chemical engineering from the Technion, and a PhD from MIT's Department of Material Science and Engineering. He is recipient of multiple awards and the co-founder of the medical device company OmniGuide Surgical Incorporation. He served as the founding CEO of Advanced Functional Fabrics of America, AFFOA Institute, a public-private partnership backed by industry, academia, and government. AFFOA is aimed at accelerating widespread commercialization of highly functional fabrics. And I am Claudia Van Born. I am the editor-in-chief of all textile technological publications of the DFV Media Group, with a million publications, Technical Textiles, Nonwovens Trends, and Chemical Fibers International, as well as the online platform textiletechnology.net. And I'm your moderator for today's discussion. So let's start with the first question. How do you see the current importance of smart textiles in the context of the textile industry worldwide or Europe-wide? Mr. Kieran, would you start, please?
Yes, thank you. And thank you also for the introduction. So if you see only the market volume of these smart textiles was 1.3 billion in 2031, it's only a small volume. If you compare this with the 1,000 billions in 2020, which have the textile market generate worldwide, it's only a small piece. But on the other hand, if you compare, or when you see the market trends which are out in the markets, that means the silver ages, connectivity, and all these other topics of these mega trends, then you see that these smart textiles is an how to say, a bridge for the technologies. That means now you have smartphones, you have smart watches, smart speakers for each kind of application, a small device. But for the textile industry, it could be a chance that you transfer all these technologies in once. It means in a kind of an everywhere. It means you don't need a special speaker. You wear it with you. I think this is the target. And this is also, I think, the transfer from the textile in the digital age, I would say.
Yeah, thanks very much, Dr. Seneco. How do you see that?
Hello, and thank you for the introduction. In a digital environment, we are more connected now. And the fabrics has to follow this revolution. Today, the fabric is quite static. So we have to have the fabrics becoming more and more connected, and you have to integrate more and more technology in it. So fabrics have to be connected, providing dynamic information and response to the environment. Fabric is everywhere, in our life. Wearable cloth, reinforcement in a car, and so on and so on. If we have just static fabrics, I think it's quite very sad for the future. So for me, fabrics have to be very smart, and I would say the strong strength for the future to have the fabric smarter and smarter.
Yeah, thanks a lot. Professor Fink, you are the third in the row.
So I'd like to offer maybe a few comments on what smart textiles means to me. And I think about smart textiles in terms of 4 layers. The first layer are fibers, and fibers that have very sophisticated functions, not just conducting electricity. Wires are not smart. It really is bringing semiconductor technologies into or within the fiber level. So that's layer 1. We call that the Moore's law for fibers. Second layer is combining functional fibers into fabrics, which are computing fabrics. That is the second layer, where the fabric doesn't have a computer glued onto it, but the computer is the fabric. So that's layer number 2. Layer number 3 is incorporating AI and machine learning into this surface to be able to make sense of everything that the fabric is picking up. And layer number 4 is offering value-added services to consumers. And so the fabric industry is transformed from a goods-based industry to a services-based industry. So these are the 4 layers that we look at when we talk about smart textiles. And for us, it really hasn't really begun. So what number of billions is going to be in 3031? I think that number, or in 2031, is, I think, a little premature. I don't think this revolution has fully started.
That sounds perfect for the future. Thank you very much. There are innovations in all areas. For example, new conductive fibers, stretchable electronics, energy harvesting, energy storage, logic, and memory. In your opinion, what are currently the most important or interesting developments in the area of smart textiles? Mr. Kieran, would you start again?
Yes, thank you. Also, I see the material side at first. So there is a lot of movement inside, and to integrate more and more function, for example, in a yarn. I see here also the A4 yarn of Professor Fink, which we try out on our machines as well, that we integrate all the sensors in one textile. So this is our professional, this is what we can do. The other one is the connectivity, so that the textile has a transfer from with all these electronic devices, with Bluetooth sensors, also for the energy. Here, the connectivity or the connection between these 2 worlds, textile and the electronics, is one other very big point. And at last, or at least, I would say, is that this emotional, which are some companies try to transfer with the apps and with the showcases which they are providing, that they show on a huge screen, for example, the heart rate of the athletics, that the fans outside can see what they are doing during the downhill run or something like this. So this emotional of these things, that when you go out for running and you come back, that you get this feel from your device that it says it was a good running for you, it was a healthy running for you. I think this is also another thing where is very important for these technologies.
Dr. Seneco, how is your opinion on that?
Yes, for me, there is two things that is very important, and one thing is more for the functionality we can bring from the fabrics. The first is a capacitive technology, and you have the fabrics, and the capacitive technology help you to detect where you are from the surface. We have the contactless technology, we have the distant technology, and so on. It's the first thing that we can imagine. And one example I could see based on for the capacitive technology is to use it in a car, and when you sit on a car, able you to manage, to measure the distance between you and the seat. And then if you have to use airbags can deploy in different ways and optimize the position for you and to be for you safer. Second thing I could see for the development is the heating. You can see heating is quite easy to heat everywhere. But for me, so the idea to be innovative here is to bring in the same parts heating system on the probe to measure the temperature at the same time. And then we can imagine here having the more consistent, I would say, temperature everywhere on a big surface, but also optimize the energy because you don't need to use a big wire, big system and so on, just the fabrics, 2D fabrics by heating and the probe to measure the temperature in this place.
Thank you, Dr. Seneco. Professor Fink, what do you think would be the most interesting or important development?
Yeah, I think we've consistently failed to really predict what is the most important things. But I think it's good to point out, at least in the way we like to think about this, is what do we need in order to realize a computer? When we talk about something smart, what we really mean is computation. And so there, it's pretty simple. You need analog inputs, sensors of different types. You need a way to store the information digitally and process it. So that's memory and processing. You need a way to communicate. And finally, you need energy. And all of those components need to be realized in fibers and in yarns, and then built into fabrics. So that I think is sort of the work we have ahead of us. And some of it's already happening. Maybe a lot of it is already happening. So I think we have a very bright future here ahead of us.
Again, a very positive ending. So thank you for these exciting insights. If we now take into account your insights into future developments, we obviously come to the next question. Based on the trends and developments of smart textiles, how do you see this will impact or influence textile manufacturing technologies? Mr. Kieran, we would like to start with you again.
Yes, preferably, from my opinion, nothing. So we are perfect in this, what we are doing. We have a high efficiency, we can offer a good price. So from this point, I would say nothing. So, but on the other hand, I think there, if we see all this new technology which comes up also with this smart textile, I think we have the chance, for example, for production on demand. This is one big point, that all these specialized textiles at the moment, which we need for this, will produce in the market where we need it, and for this we need also this production on demand. This is, I think, one big point. The other is the personalization of this textile. If you see the sensors for a body of women or for the man are completely different. Also for smaller people, taller people, they are different. I think here we also need a small personalization of these, especially for healthcare. The other one is that we try, for example, with these experiments, what we have done with the textile circuit, it means to try with this tailored fiber placement, that we bring the smart textiles in a position that there is no big difference between a normal shirt and a smart textile shirt. Also for this cut and sew process, for example, which comes after the textile production, that there is no big difference, that the sewing ladies, sorry, in most cases a lady, that they see no difference, that they can make the work which they know. And this is the other target, for example, for this life science, when we try to bring this technology in a mass market.
I see. And Dr. Senecal, what kind of impact do you see?
For me, I would say for the smart materials, I could see three pillars for me. The one is the technology to make smart materials. And secondly, we have to consider also the electronics you have to bring to use the smart materials. And the third pillar for me is the data we can generate with the materials. So for me, the impact influence we can have to develop the textile industry, the smart textile, is considered not only to provide materials, but also to consider electronics around that, and to ensure now for the textile industry, not considering only materials, but also, as I already mentioned, understanding the electronics as more able to design electronic dedicated or suitable for the fabrics. And then at the end also, for the third pillar is concerning we are going to generate data and then understand how we can treat this data, how we can collect this data, how I can use the data to serve the customer as well. It is for me the influence, the impact we can see for the textile industry for the future, not only providing only materials, but also moving, as you can see for other company, on electronics and managing the data. It is for me the more things I can see here.
Mm-hmm. And Professor Fink, what do you think?
So I think it's going to be a very interesting period to really consider the revolution of this industry. Again, if you believe that textiles are going to transition from being a good to being a service provider, we could maybe start imagining very different margin levels associated with services. And the question I have to the equipment manufacturers, considering the fact that a lot of the value that is going to be provided is going to be in the services, would you like to continue just to stay in the just equipment level, or do you want to start thinking about more of a vertical integration where your equipment really takes advantage of the value it's providing to the end user? Now that I think is a good open question. You could think a little bit about what's happening in the semiconductor or phone industry or smart device industry, and how the stratification has occurred there. I'm not sure that's going to happen in the textile industry. Maybe it's going to be some other version. And so that's, I think, a very interesting question.
An open question at the end. Thank you. Thank you for your opinion on that. Currently, there are many interesting innovations. For example, in the areas of conductive inks, wearable technology, printed electronics, or the Internet of Things, and so on. But so far, we haven't talked about sustainability in this context, which, after all, is important for all areas of our lives. So the next question is, what are some innovative technologies that will spawn smarter materials? And what will the impact on sustainability be? Mr. Kieran, of course, you are the first again.
Thanks once again. I can't answer the question of the technology, but what I can show, or what I see, is if we can give the textiles, starting from the yarn or maybe starting from the polymer, the information what we need for the textile chain, for example, and we can all add this information which you have in the stages of this textile chain. I think this is one good possibility for the sustainability of these textiles, because here we can add all these things with traceability, for example, and we have all informations what is done with this material. Is this a recycled material? Is it a virgin material? All these topics. And then we can bring this, if we see in the textile, in the finished textile, or in the garments, which kind of material is inside. then it's also, I think, easier to have this in a circular economy, that we see, okay, this is 100% of polyester, or this is a mix of polyamide and elastic yarn. I think then it's easier to bring this also for the recycling process. And I see that here information which we can position inside the textile on an electronic way, that everybody can see it with a smartphone, with a scanner or something else. I think then we are in a good way to use this technology for sustainability.
I see. Dr. Senecal, may I ask you for your opinion on that, please?
Yeah, for the sustainability, I would say I can see two things. The first obvious thing is using, of course, recycling materials or polymers that we can recycle easily. Of course, it makes sense. But other thing that I have in my mind here is as we can bring functionality on fabrics, and we can combine together different functions and reduce, I would say, the different steps. And when you reduce different steps, you can reduce the environmental impact. I am thinking about for the wire, for instance, in a car or everywhere. Today, you have to use wire, you have to use connection and so on. And if you're able to print and to directly on the fabrics, you bring reinforcement function. And then also you can use the fabrics to put the wire in it directly and to reduce the amount of materials. It's one thing, you can combine different functionality and the same materials, and then you reduce the impact, environmental impact. Second thing is that we are thinking about is using by recycling different kind of yarn, new yarn, and so on, working on the interface, using interface with a low impact, low environmental impact. Today, to treat the fabrics, we have to use water, you have to use chemical treatment, and so on. And this is how we can treat the interface differently to combine the ink and the fabrics together to have a better shelf life and also to have a lower environmental impact. It is that we are thinking about the sustainability.
Professor Fink, what is your opinion on this extremely important topic, I think?
Well, I think the question we have to ask ourselves is, why do we have so many fabrics, so many pieces of fabric hanging in our closets in the first place? Why does that happen? Why do we all need 20 shirts or quite a large number of dresses or pants? Why is that the case? Why are we fine with just having one phone but need 20 shirts? The simple answer is that the phone is programmable and is multifunctional, and every time we need something, the same device could provide us that need because it is dynamic, it is programmable, and it allows us to meet a large variety of needs. Now, I think we're moving towards a situation where a single fabric will be able to dynamically change and provide us with a lot of different needs. And that could be heating, it could be cooling, it could be different color, it could be a different design. So there's lots of, and in that world, you really need only perhaps one fabric. So I think the question of sustainability begins with the question of, why do we need so many things in the first place? If we only needed one, then the waste stream would be significantly smaller. And that really has to do with being able to dynamically program fabrics. And so that's what we're talking about. We're talking about accelerating the value of the fabric, and something that you really value, you don't throw away that quickly. That to me is really what sustainability is about, appreciating the value of fabrics.
Yeah, thank you for sharing your observations and insights into the topic of smart textiles with us. For many years, the textile industry, as well as scientists and designers, have been exploring and researching into smart textiles and functional fabrics. I hope that the insights, perspectives, and opinions from our very interesting panel of industry experts have been thought-provoking as we move closer to a future where fabrics are functional and responsive. I would like to end this panel discussion with the prospect that we are looking forward to seeing some of the exciting smart technologies live at the ITMA 2023 in June 2023 in Milan. Thanks a lot and see you soon.